Next 10 minutes, we're going to be talking about graph analytics and graph machine learning. This is the relevant way to increase the efficiency of any business area. So the CEO, Ilya Pozdnyakov and Mikhail Stepnov, are going to tell us about how graphs are used by Sber as of today. So the floor is yours. Over to you. Thank you very much, Dmitry. Good day to everyone. So I'm the head of the technological team, which developed the graph platform and a big number of services in our data library. We're using Sber, and Michael's team deals with different data science magic, which allows improving results based on AI models and graphs we are going to tell you about today. As of today, the graph platforms for Sber is just beyond the experiment mode, so it is serving for the business purposes. So the graph platform is used by 14 different business departments representing all the areas of Sberbank business. And the figures are in front of you. So in company business users, 3.8 thousand, and we have around 100 data scientists in the video graph labs creating new graph models or layers. But the most interesting thing is that any client of Sberbank applying for a loan or is going to apply for the loan who is a user of our graph platform, and today we're going to tell you why. So let's start with what the graph is. Graph is a mathematical object describing links or edges between entities. On the slide, you can see a very simple graph. But this is a big graph. This is the graph of the whole web. These are different graphs representing not only internet, not only people, but molecules, neurons in the brain, everything possible. There is a sting graph, the scene graph, even this 3D model. This is a dolphin, it's also a graph, so it's great. So with the help of graph, you can represent any information in a very convenient way for the analysis.
And this is the piece of unexpected news, because lots of things happening around can be represented with a graph, and you can get unexpected results. Now comes the graphs analytics. Appeared long ago, but of late, alongside the AI development and data processing, more and more companies want to deploy graph analytics to serve their businesses, because the density can provide additional properties that you will be able to use in your machine learning. Gartner has included graphs as one of the top 10 data analytics trends in 2019-2021, and half of the clients and the interviewees wanted to invest in that, and we don't trail them. Sber has been investing in analytics for a long while, and we have been able to create a cobweb of ties with our clients, and we have improved the number of business processes, and we have expedited and accelerated our business process, and visualization is now at our service, and with our own eyes we can see the non-obvious links and patterns and causal things that we may use while investigating fraud or something else. When we looked around when we started, and there are around 40 graph engines today, looking at the needs and the data volume and the data set, we conducted several experiments, and we found out that nothing suits us, we thought back then, and we invented our own graph platform with the graph engine, which is called FastGraph. done with Scala and the Scala, and graph should be quite a light thing and should be placed on the cluster of servers or a server. This is why the graph processing speed is very high. We use this Stack Apache Hadoop technology, and we store that to store graphs. We use Solar Elasticsearch to find data within a graph and do that quickly. And we're now capable to work with billions of ties. It is agile and flexible, and we can tweak and fine-tune that, and we are safeguarded against all sanction risks. These are the 7 services that we offer at the platform. The FastGraph database is in the core. We have a graph lab. It's your favorite. Yes. You can press a button and it unfolds, and you can see the necessary makeup of the graph services. You can come up with a model, then batch graph calculations. We use that to calculate our big graphs, huge graphs, and graph embedding is shaped with the help of this. It is a long vector of graphic metrics that characterize each of the nodes, and this is the gateway to the magic, and this is the depersonalized image of our clients. And then comes the graph neural networks, allowing to build GNNs using popular GNNs libraries and online access. Then comes the single graph of client connections, the joint graph of client connections, and visualization also. And all our country fits into a graph of clientele. In our graph we have 13 billion ties or links. We gathered more than 500 documents and produced 107 million entities out of these. These are nodes. We have 128 link types, and we have been using lots of data sources, and definitely we store 5 years of history, so that further on we may use this track record for the sake of the AI development. And now with this graph we are on par with the Google graph of knowledge or Alibaba graph. And we received a number of new capabilities that we never had before, like we can work with related borrowers or related groups to assess the level of risks. We can see the most influential nodes or entities. We can investigate anti-fraud cases, and this is only a tiny part that can be done without data science, but the tastiest things are within the graph models, and Michael will tell you about that. Yeah, talking about visualization is good, and still the AI journey would require talking AI. Otherwise it would be a blasphemy. So we need that, and we have a lot of that, and all the nation or anyone who borrowed from Sberbank are now the users of the graph embedding platform. Probably all of the scientists know, data scientists know the power of the graph embeddings. But the graph embedding is one of the strongest tools for your business, to boost your business. Any business user or data scientist, like if he or she wants to issue a loan, would wish to use all the information about the target individual and his interactions, social interactions. But you know, sophisticated analytics takes a lot of money and time. But if you train the graph neural network, and if you take the embedding layers, you may use this vector, this embedding in your models, incorporating the description of this or that essence in your model. The business outcomes are obvious. It is given in the slide. It is just the beginning, only the beginning. Apart from this fundamental feature, we have a lot of projects with ecosystems, for example, like Rexis graphs are used by Amazon in their core business, for their core business, and graph and evolution networks to assess the arrival time for double GIS. And DeepMind's case by Google is an inspiration for us, and our proprietary product Digital Manager, aimed at improving the business decision-making by the top managers, uses the knowledge graph. Together with the NLP, we extract facts and info from digital footprints of the leaders, decision-makers. I mean the correspondence and meetings minutes. And this is like a interactive reference for them, voice upon request. And today I think we are on the right platform to make an announcement. We have created a transformer model. Starting with 2018, deep learning is all about transformer models. We now heard about a transformer generating pics. It's about true DALI. And the transformer is now about graphs also. Graphomer is the new invention by Microsoft, and definitely they beat all the GNN and CNNs in terms of accuracy. But you know, we outperform the Graphomer by speed, but our net is 2 times smaller in terms of number of parameters. It is the first network that we can use now. It is second to Microsoft, and that's not that big, so probably the sky is the limit. It isn't a scientific application, and we will introduce that for industrial applications, like the pre-trained Graphomer can be used for credit scoring and anti-fraud monitoring to enhance the efficiency of these models. Graphomer works by an NLP model principle, but it has been pre-trained for a language structure. And our model has been pre-trained with a graph structure, and the data scientists can also take the final layer and train it additionally with its targets and receive a highly efficient model. It is ESG also, because advanced teaching, advanced training is much more nature-saving than training from scratch, and the graph embedding recovery pace increases 13 times. Then come the knowledge graphs. It is a means to store information from different patchwork of sources in a single structure that you can turn to. You can see that in our client graph we have 128 types of links, and the knowledge graph has an infinite number of links, and the main goal, the main task that the graph researchers face is to collect information into and supply information into that graph, you know. Graph is one of the possibilities and ways forward for a powerful AI, general AI, and we all dream to arrive there at the end of the day, to accomplish there. I hope I hope that we'll be able to tell you during the next AI Journey conference how we established a AGI with the help of the graph embeddings. And now let's talk about something more down to earth. Together with Pomeran Laboratory and Mr. Sergei Nikolenko, a wonderful person, and we have come up with a BERT model. It is an information extraction based on BERT model, and we used patterns for OG detection. You can see how it operates. The motion is given in the screen. So it is the first model of information extraction in Russian, but it is also multilingual. It works with high accuracy for several score languages. With respect to sky rate, we have done extremely well. Another project of ours about the graphs of knowledge is working with a single graph semantic layers. Like, for example, fancy your big company buys tens of thousands of MacBooks from hundreds of suppliers, and to buy a batch of MacBooks you have an invoice, and all of a sudden you want to buy a new batch. So you either, and you start noting that kind of money starts leaking from your account. Probably that means that in your contracts you had some con artists, and a normal person would sift through those contracts, and it is not guaranteed that they will find anything. But by the help of our graph projects, we can extract essences from documents and put them in a single graph, and we can turn to this channel quickly, or transfer it, convert it into ABI interface. And the con artists will be found, the dragons will be slaughtered, and the princess would be saved, and the best suppliers would receive a big batch of MacBook, or an order for a big batch, or TGX at Quiz Safari. You can buy them. That brings us to the end of our presentation. Michael and Ilya, thank you very much for your interesting presentations. Several questions. One of them lies at the surface, like the mere idea of using graphs and links between essences or entities has been around for quite a while, but Michael, probably you had it in your slides. Why this graph analytics became trendy only in 2019? And that was at Ilya's slides, but let me respond, because when we speak about the computing power, it is about data science. Graphs are a flexible tool that can help resolve a number of tasks and problems, but the calculations of a graph network is energy and labor intensive, much more energy intensive than training a network to deal with a text, because, well, a picture is a graph. It is a set of pixels that are at a fixed distance from one another, and the distance in graph can change, and we should look at the vertex and apex types. Well, in a nutshell, there is a boom of works with the graph machine learning, because supercomputers and DGXs emerged and the cloud computing emerged, and we can quickly calculate these big graphs. And there was an enabler, as it happened, and the computer power growth has accelerated. And my second question is about baselines that you also have shown. If we compare the state of the art neural network models and the classical boosting models where you can use graph features, which is also feasible, like what is the quality ratio or correlation here. Probably once again I will have to respond. I would not recommend comparing G-boost and the graph networks, because a graph network is quite heavy. It requires considerable computing resources, but what we need is a graph embedding, and the approach of the graphomer is about the fact that we can receive the graph embedding efficiently and supply it to AIJ boost, and we'll have a light-weighted model, and the graph info will be taken into account by the model. Let me add that stack Hadoop that we use to calculate our graph and create it, well, we spend a lot of time to tweak that at Apache Spark to build this, and the stack Hadoop has been used as a production development and discovery like for 5 years. Still surprised us and astonished us in terms of stability, inferiority back in 2018 and 2019, and what we need is to be able to stably calculate the graph once a day across the country. Michael and Ilya, thank you very much for your presentation. It has been a very interesting one. We would move on.